Hello students, welcome to the lecture 2 of week 3. So in the past lectures we have seen the various Linux commands that we can use. We have also seen that what is Linux and why it is helpful for bioinformatics. And the command that we discussed were the routine command that you will often use when you are doing any file handling or any analysis on Linux. Okay, so we will do a quick brush up of those commands, and then also we will then proceed to see that how actually you will be running the jobs on Linux, and how to install the various packages that you generally use for genomic analysis. Okay, so basically the way these packages are installed and their paths are defined is a standard process, and the things that we will discuss today will be sufficient, I think, to cover most of the available options that comes with the package for the installations. Okay, so we have seen that basically things started with Unix operating system, and it was proprietary, and also there was Minix which was available, which was used to develop the Linux operating system. And basically advantage of Unix is that or basically Linux which we are dealing is that it is allows multitasking, allows you to use your system's hardware and software better. Allows you to tweak with the system. It's an open source, right? Whereas Windows is a closed system and proprietary and does not allow you too many options, and also suffer from viruses. And so these things we discuss, and basically today, like, so many tools are available for Linux, for various bioinformatics applications. Okay, whereas such tools are very rare for Windows, but some are there. The problem is that because it is very difficult to use all the resources in Windows as compared to Linux. And there are various distributions, like Ubuntu is the most common one today, right? Then Fedora and Red Hat and CentOS. Okay, so basically Ubuntu, because it is lightweight and it gives you a nice desktop also, right? So basically when you start a terminal, it looks like this. Okay, so this is your GUI page on which there is an option to start the terminal, and when you click here, it opens up the terminal like this, where you can run your command or jobs, right? And when you log in, basically you will we discussed in the last class that you would like to see that where you are by present working directory, or and list of files in that area. Okay, so generally when you log into your /home/user. So whatever user you have created at the time of installation, you log into that user account. Okay, and Linux is case sensitive, so whatever command you are running has to be in lowercase. Right, so these commands we discussed in the last class, but just a quick recap. ls basically gives you a list of the files in a folder, and it has area of several options. To change a directory from current path to another path, and like that, you have to do cd, change directory. Okay, and it has several options, like moving to the home directory, or going back one directory. Okay, cd/dot, and so generally dot is your present directory, and dot is the previous directory. So if I say like cd dot, so basically it will do nothing and it will stay here. If I say cd dot, it will go one directory back. If I say cd dot, it will go two directories back. Okay, so this way you can go back, and if you want to go further, then you have to see what directory you want to go deeper into the directory list of or arrangement of folders. And then in between you can always check by present working directory that where you are finally. Okay, then we discussed the command to copy file. Like if you want to copy file A to file B, make a copy of like file 1, then you can say copy file 1 to file 2. So basically now you will have two files in your folder, file 1 and file 2. A copy of file 1 is now file 2. If you want to rename file, so basically you will do rename file 1 to file 2. So when you say move file 1 to file 2, basically file 1 will be gone and file 2 will remain, right? So you have, what you have done is you have moved file 1 and renamed that into file 2. Okay, However, if this is a directory, okay, the destination which you are writing here, okay, if it is a directory, then basically this will be moved into that directory. So move can be used to move something and also rename something, right? Then to remove a file or a directory, you can say rmdir or rm file, right? And to make a directory, make directory and mkdir and the directory name. Okay, we are doing a quick brush up because we have already done these things earlier, right? Then to see the content of a file, you can say cat file, it will display the contents of a file. Okay, less and head and tail can also do the same, right? Less is more iterative, and head and tail gives you just the top and bottom of the file. Okay, then to find any pattern or word in a file, you can say grep that keyword and file name. So it will give you list of lines that contain that word that you are searching. You want to know how many lines you have in the file, you can say wc minus l. You want to say how many characters in a file, you just say wc and the file name. Okay, now you want to know what process is running in a system, you can say top. Okay, it will list you all the processes with the PIDs that we seen in the last class. Okay, now if you want to like free memory for various purposes, like there are some memory which are idle or like that, so you can say free minus h, okay, or minus g. To kill a process, you can say kill, and the PID you will get from here. Top will give you the PID, and that PID you will use with kill minus 9 that PID name, or just kill that PID. Okay, to compress and uncompress, you use zip and unzip, which are available. Okay, to make a bundle of files, like you have multiple file like file A, file 2, file B, file C, file D. Okay, so what you can do is like you can create a bundle of all of those together instead of moving them to a folder. Okay, one way is that you create a directory and move all the files inside and then zip it. Other way is that you can list all the files and create a .tar, okay, which will contain a compressed or a bundle of all the files that you want to okay, like archive.tar. Okay, and in front of it, whatever file names I will give, all those file names will be compressed in archive.tar. Okay, then if you want to now again get back those files, you say tar minus xf, so it will get back all the files that you were created a bundle earlier. Okay, and this is to see that what is the storage used by various files, du minus h s. Okay, okay, then each file has some permissions, read, write and execute. Okay, so which is like if you do ls minus l, it will tell you that what is the permission level of the file. So one is for the so this one is for public, so basically you want to always specify what permission is for the public and what permission is for the user and like that. Okay, then you can also change the file permissions using the command like chmod. For example, you have created a program, okay, a.pl, which is a Perl program, so you want to make it executable. So what you can do is like chmod plus x, basically you are asking it to and a.pl, so it will make this program executable, right? So the color of that program also changes in your directory. Otherwise you have the options like chmod, for example 777. Okay, so this will make it like read, write, execute all together, which we do like very rarely. Otherwise you can always restrict the permission by using this codes, which are 7, 6, 5 and 4 for read, write, execute, read, write. Okay, read and execute only and only read only. Okay, so this way you can give these codes. Now Linux, okay, so for example you are running a any command or any program, so like you did head -10 and a file name. Okay, so basically what it is going to display is the top 10 lines in this file. Okay, now you want to save this file, save this data. Otherwise if you just type this much from here to here, it will list all those top 10 lines in your terminal. Otherwise you can use a redirect symbol, okay, and give any file name. Okay, you don't have, you can create a new file name here. So whatever is the output of this part, okay, will be stored here. So the 10 lines that you saw in the terminal are now saved in this file 10 _ fruits.txt. Okay, so basically you are putting the outcome of something into this file. Okay. Now another thing is append mode. So this is like, okay, so if I again use this symbol for the same file name, okay, so it will delete the previous content of this file and put something here. So for example, if file already exists and you have used this command like this redirect symbol, so outcome of the whatever process you are running, okay, will replace all the contents of this file if the file already exists, and if the file is not existing, then it will create a new file. Okay. Otherwise what you can do is you can use append mode. So basically the contents whatever were there in this file, okay, will not be deleted, but actually whatever is the output of this will be appended to this. Okay. So basically if it contained 100 lines previously this file, so now it will be 100 plus 10 lines. Okay. So these things we have to be careful. Okay. And then the next important thing is like piping. Okay. So you can always combine 2 or more commands in Linux, like we did like head -10. So I am asking I want to know the 10 lines in this file, top 10 lines. Okay. So head. So and then also whatever lines come, I want to sort that, right? So I will use a pipe symbol, it is there on your keyboard in between. Okay. And then type the another command. So the output of this, whatever is the output of this, will go to sort command, and it will sort that output and give you the output in display. Okay. Now if you want to save that output also, I will say this part. So there will be some output from this part which will go as an input to sort. Sort will sort it on the basis of numeric which you have defined, sort -n, and the output of this will be saved in this because you have put a redirect symbol here. Okay. So this way you can combine multiple commands in Linux by using the pipe. So pipe and this redirect symbol are very important. Okay. So this we discussed like this symbol, append mode and redirect mode. Okay. Then the pipe mode, combining 2 commands. Okay. Then similarly like in cat we were displaying the contents. Now if I want to display the contents of 2 files, file 1 and file 2, okay, and then redirect both the files into another file. So this can be used to concatenate also. So cat file 1 file 2, that means concatenate file 1 and file 2. So file 1 contents and then file 2 contents will be concatenated together into another file which is called file 0. Okay. So basically these are just this is the file which is there in your directory, and this is the file that you created on runtime. Okay. So if there is no pre-existing file called file 0, it will be created new. If there is any pre-existing file 0, then be careful because the content of that file will be deleted, and a new file with these 2 contents will be created, which is called file 0. Okay. Then sort is to sort the data in various modes, and man sort will tell you a lot of options in sort. Who is for like who is there in like logged in, or who all are the users which are logged in. Okay. Wildcards we have seen like there are 3 ones, star, okay, where you do not define anything, and each and everything, okay, which is present there will be displayed. Okay. Like ls star will display everything which is there. Okay. But if I say ls star pl, so anything which has the suffix pl, right, will be displayed, right. Now this is for a single character. So like for example, you can say that first character matches can be anything, but the rest of the file has to be exactly like file 1.txt, file 2.txt, file 3.txt. So I will say file .txt. So all the file 1, file 2, file 3, whatever are there, okay, will be displayed, right. And this is to give a range that from where to where you want the characters to match, and those will be displayed here. Okay. And if I say like remove star.txt, it will remove like wildcard usage. It will remove all files that have a suffix txt, right, from your current directory. Okay. So if your current directory is root, okay, you will be removing everything which is there in the all subsequent folders. Okay. Then to get help or details about anything, you will be using manual or mangrep, which we have done earlier, right. Now coming to another part. So far we were doing a quick brush up of what we did earlier. Now basically sometimes like the same set of commands which, okay, by changing some file name or right, you are using again and again. So you can always create those set of commands into a small script, right? So you can write all those commands in a the way they want to execute them in a script, right? And this way, like you can give a executable permission to that script file, and then those commands will be run. Okay, so basically don't have to retype all the commands all the time. You can create a put those in the small file, okay, and then run those commands. So for example, this is a file called bash script.sh. okay, so whatever commands you have put in this file will be executed. So by putting sh this, or you can just type that /bash, so this will also run this. Okay, so there are two ways of running a script file. One is sh, the file name .sh, okay, or second is / and the file name. Okay, so this way you can okay, and by name convention you will always put .sh after the script file, okay, after the basically the file which is your script where you have combined the various commands or anything that you want to do again and again. Okay, so like this is a script file, okay, which we have created earlier. So now in this file there are different tasks. So like first task is like cut a column, okay, -F2 second column from this file and put it in this file. Okay, then sort this file which is there, okay, and sorted file will be saved here, okay, into sorted file.txt, and then grab the n50, okay, from any other file and put it into this, right? So this way, like different tasks, like, or then echo in the end you just print that the script has finished running. Okay, so basically 4-5 type of jobs that I want to do, I have written them in a single file, and you should see that I am putting hash in the lines which are informative, which I do not want to run, which is just an information, that you can say indentation or just some kind of information for somebody that okay, this line, this command is to do this job. Okay, so kind of small description of what you are going in that command. So if you put a hash in front of this, that line will be a commented line and will not be used. Okay, for it will not be considered as a line which is going to run. Okay, and when you run this, so it will do all the jobs that you have told, and in the end it will print that script has finished running, which you have put here. Okay, so that means all these commands have successfully run, and now okay, your last line is printed. Okay, that means there was no error and all the command that you have run, and okay, with just one script file. Okay, then another thing is that you want to install packages on your Linux system, right? So there are different ways of doing, and depends upon the package also, and the packages that you want to install often have dependencies because they might have used libraries, right, or sub programs or functions from other programs. Okay, so generally the site from where you are downloading the package will tell you that these are all dependencies you should have in your system already installed, and also tell you that how to solve that problem, and most often you are able to do so, but problems come when you are using a different version of Linux, or the package is outdated, or it's a new package, right? It could be like Perl or Python problem, like new or old, or basically the library is changed, right, or a new library has come. So you have to resolve that error. Some instructions are there on the page from which you are downloading. Otherwise you can also Google that error which you are finding, getting, and see the solution from there. Is a community like somebody else like you might have also faced the same problem, and you can get the solution from there and try to implement that. So by some generally, like software these days are user friendly and no difficulty in installing, but if you have get stuck somehow, then this is the way to resolve these problems. Okay, So basically first of the job that you want to do is to find the source code for that software that you want to install. Then you have to unpack that source code, because generally it comes in a package, a zip file, because it could be like a big package, or always a package is better, because if you download the entire package in a zip format and when you unpack on your system, so it saves you from the unwanted errors in like a single file. Like there were 10 files present in the package and you downloaded only 9 and worrying about like why it is not running. So better to download the entire package, unzip on your system, and then all the 10 files will be visible on your system, right? And then you have to compile the code, because this may not be a pre-compiled code. Sometimes it is, but sometimes it may not be, because in Linux you are using a different environment based on the Linux platform that you are using, okay, or the Linux OS you are using, okay. So mostly it is needed that the source code is, or the code that you have downloaded has to be compiled on your system using your system environment, right? And then you have to install, okay, that file, and then set the paths for the running or usage of that file, so that you can run it from wherever you are, whichever directory you are in your system. Otherwise you have to always go back to the previous place where you have installed the program and give that path and call that program from there, okay. So basically path is very important, which tells that where you have kept your program, and which all paths are where the programs, different programs that you've installed in your system, right, are basically saved in $path variable, okay. So you can put the path of a program into that variable, so that you might have like several programs in your system, right. So all those programs will be will look for their binary in that path source, right. So echo path will tell you that wherever all the scripts their programs are, okay. So like if I do echo $path, so it is giving me various paths, like this is one software up to here, okay. This is now another software up to here, okay. Then this is another path that I have put in this, okay. So basically this is another path, okay, this is another path. So these are paths are present in the $path variable. So whenever you run a program, okay, it will look for the path or these where the program exists in your system in this variable, okay. So how to do this we will see now. Now when you are installing programs, right, there are options to like libraries you want to install, or okay, so there could be some default extensions or libraries for your system, right. So you can use yum or apt package, which are generally comes with your Linux installation. Otherwise you can also install these, okay. So basically this allows you to download something directly from a repository into your system. So it will do all the checks of what system you are using, what is the specifications of a system, 32-bit, 64-bit, RAM, okay, other libraries and dependencies, right. And it will go to the repository and download everything that you need for your system for installation of that particular library or software, right, and install it in a very cleaner, faster and secured mode, okay. So you don't have, so basically it's a reliable way, because it is seeking the files in a trusted repository, okay, which could be located in your region or a global repository, right. And it can do various jobs such as update, install, remove, list or search, and these kind of things, okay. Like for example, if RAM is already there in a system, then you can always check that what all you can do with yum. So basically yum minus help. So this thing minus help, yum space minus help, okay. So this is one way by which you can know. So like if you type any command and space minus help, it can tell you that all the options which are available for that command, okay. So like list of commands that you can use here is yum check, yum clean, yum downgrade, yum erase, and like that, yum install, right. So install a package for your system. So I will write yum install and the package name, Okay, so it will retrieve the package from there and put it in your system. Sometimes it could be that you will need the root permission or sudo or su permission. Su is root, okay, sudo is okay, the way you execute the root for this installation of a package. So that also has to be looked into. Okay, so for example, BLAST is one software which is available in NCBI, which is for the local alignment of sequences, right? It has various options of nucleotide alignment, protein alignment. We will see this in the next few classes, but since we are dealing with the installations things here, so I am just touching upon this topic, that how to install BLAST. Okay, so what you will do is you will locate where the BLAST is. Okay, so like you can find more information here. Then on your system you can say like sudo apt get. Okay, so yum is one option and apt get is another option. Okay, apt get means you are getting something from using the apt command. Okay, and sudo is to execute the super user permissions, that sudo, like super user is doing a job. Okay, and if you are already a super user or basically the administrator, okay, you can run it directly. Otherwise it will prompt for a password and you have to enter the password in the next line when it is prompted, that you have to enter the password of the admin. Okay, so sudo, okay, and do this job and install this, right? So sudo apt get install, and this is the package name. So it will basically download that. Okay, okay, so package you can download from here. Wget is the command to get something from net. So basically this is the path. Okay, so if you see the on any browser page, there is always a path. Okay, or you can just do right click and you can know for any program you can do right click. Okay, and you can know that what path that program is like. Okay, right? So basically you can copy that path and paste here. So wget and path is the web path or web directory from where you want to download it. Okay, so that you will do. So wget will get it from there and put it in your system. After that you will decompress it using tar minus zxvf. Okay, z is for decompress, okay, uncompress. X is for basically extraction, right? It could be a bundle of files. V is for verbose, that means whatever it is doing it will be printing on your screen, and F is for file. Okay, so basically zxvf and this .tar.z file, it will uncompress in your system. So when you have done this, you will like to know that what has happened, like where you are right now. So you will say pwd, it will that okay, whatever your current directory is that, and the BLAST folder where you are actually uncompressing all these things. So you created a folder called BLAST, okay, before this, and then you are doing all the installations or getting something from web in this folder. So this file is now in this folder. Okay, then when you say ls, so basically it will tell that this is the file that you are containing in this folder. Okay, then you will go to this folder, right? Okay, this is the folder, right? So when you go to this folder, you will see that there are several things, and one of those things is bin. One folder is bin. So bin is the folder, binary folder, where all the files for any program are present, right? So it's a pre-compiled version of BLAST, and so you don't have to do the compilation on your system. So you do cd bin, then present working directory pwd. All the binaries which come with the BLAST installation will be in this directory now. Okay, and then you want to add this path of this binaries to your path variable, so that from any folder or any place in your system, okay, you can run the BLAST executables, right? So you will say export path equal to, so this is the syntax for this, that means you are exporting the path of this directory. Okay, so your current directory, okay, BLAST, NCBI BLAST, this which you just downloaded, okay, in that is a bin folder, and bin contains all the files. So the entire path where you are right now, which you got from pwd also, right? Okay, so this whatever is the output of this is your path. Okay, after doing all this, so that path slash and colon and add to dollar path. So this path will be now added to dollar path. So now when you do echo dollar path, so you will also see this path in your echo dollar path list. So that means now BLAST is available in all the binaries or all the executables of the BLAST or programs that come with the BLAST. It could be BLAST P, BLAST N, or basically protein BLAST or nucleotide BLAST. You can run from anywhere in your system. Okay, so like this is present working directory. Okay, and now this is also your path. So if I show same thing, echo path equal to this directory, okay, and then colon and dollar path. So it will, you know, put all this which are coming with in this binary of BLAST, right, add these to my dollar path variable, and you can run all of these binaries. Generally you can see it is colored green, right, these are all executables, right, and you can run from anywhere in your system, right. So basically in BLAST you can get the executables which we are discussing in the previous slide. From this is the FTP page of BLAST, in which there is a folder called executables. You can download the executable from there. Then there is always a database that is needed for BLAST, which is a reference database against which your sequence will be aligned. Okay, we will discuss that later, but just to tell you like where things are. So it is there in the BLAST DB FASTA. We know FASTA format, right? So now whatever we are downloading will be in the FASTA format. Okay, so nr.gz is something that I would like to download because that will be non-redundant database of the protein sequences. Generally we use these as the reference database. Otherwise Sysprot, PDB, the things that we discussed earlier, right, are also available as a compiled database, okay, which contains the information of all the nucleotides or proteins or PDB or Sysprot sequences in these respective files. Okay, so this is that executable folder where you can download the either the RPM or the source code. Okay, generally you prefer to download the tar.gz, the source code. And basically if you want to run it online, this is the BLAST page. We'll be doing this later, but it has the options to do online nucleotide, protein, and these kind of BLAST. And the advantage of doing this locally is that you might be dealing with thousands of sequences, and it may take like forever in doing the online BLAST. If you want to do just 1 or 2 sequence, you can do online, but otherwise you would always prefer to have a local database and local execution of BLAST on your system. Okay, otherwise you will be copying your sequence here and choosing the program that you want to use and the appropriate database, and it will give you the result. Okay. Okay, the other way is that you can install from source. So BLAST was pre-compiled, but many times you want to install programs from source, such as ClustalW is a program for multiple sequence alignment. Okay, and you can download it from here. Okay, so same thing, the path from where this program is. Okay, copy that path from internet, say wget, have a directory where you want to like get this program. So go to that directory, say wget and that path name. So it will get the program into a local path. After that you uncompress it, tar xvf and minus, okay, xvzf and ClustalW, put a minus here. Okay, okay, and then basically this will be unzipped and untar on your system. Then go to that directory called this, which is created from this. This is the directory, the bundle of this .tar and .gz. So this will be the actual directory which you retrieve from this. Go to that directory, cd directory name. Okay, and then there are 3 steps. Although like when you see get this, you will also have a readme file there which will tell you the steps for installation. It could be install file or readme file, text file basically, which will tell you that how to install this program. You should always read that. But for this, okay, in this readme file, basically there are 3 commands that you want to do. /configure, okay, which will check the configuration of your system. Okay, after that, and give you some errors if there are some dependencies or something required. Then you have to do make. Okay, so you are making your program. and then make install. That basically whatever you have made, you are installing that program on your system. So these are the 3 standard commands that you will be using for installing a program from source. Okay, so like okay, once you have installed it, you can run it. So basically this, for running, you can, since it's a executable, just say // and program name. Okay, so it will start the program on the terminal mode. Okay, it will ask you various options that this is a program for this, and input sequence from disk and do multiple alignment like that. So first of all, you have to input the sequence, so your choice will be 1. Okay, you will say enter, and after that, when you have done that, you will be entering the file that you want to upload, which contains a list of sequences which you want to do multiple sequence alignment. So okay, and it will give you the list of files that are there in that, sequences which are there in that file, and the number of nucleotides in that file. Okay, then since you have uploaded the file into the program, you want to do the multiple sequence alignment. So now your option will be 2 on the prompt. Okay, you put 2, and then it will do the multiple sequence alignment, and then basically you want to produce the tree. You can put other options also if you want. Okay, and then it will align those sequence, and this is the alignment score, right, and export the tree as sequence.dnd. So I just gave you a quick example that basically after an installation of cluster W, how the things will appear on your screen. We'll be dealing with cluster W and BLAST in very much detail in the later classes, so don't worry about it right now. Okay, right now we just have to see that how we got a program from its source, and using the set of instructions that were provided with the program, we downloaded that program, okay, compiled or installed on our system, and then setting the path, which we did for BLAST. For cluster W we did not do. Okay, but if you want, you can always do, right, and then running the program and how this will appear on your screen. Okay, just to like feel you more convenient and comfortable with the Linux environment. Okay, and this is the outcome of this BLAST, the alignment of the sequences that were present in the file that we gave. Okay, and basically this is also available in a GUI based version. Okay, so which is called cluster X. So your choice, you can download the GUI based version or the command line based version, but when you do Linux, you will become more and more, it will find more convenient to do the things command line rather than the GUI based. Okay, and if you want to use it online, then there are so many options available, EBI site or cluster W site, where you can access that online and paste your sequence here and do the multiple sequence alignment after checking a few options. Okay, okay, then basically there is I'm giving one more example that genome assembly is one of the tasks, right, and there is a genome assembler called SPADES, okay, which is a multi-purpose assembler for genome, transcriptome, metagenome, right. It has so many tools. Okay, and source code is available here, right, so it can do genomic, transcriptomic, metagenomic assemblies, right. So again, you will do the same set of instruction. We'll get this program from the source code, okay, uncompress it, go to the directory, and just this SPADES compile.sh, there is a file. Okay, so basically now this is the change from the earlier set of instruction that I gave, and you will find these details in the readme file of this program. Okay, and this way it will be compiled in your system, and now SPADES is there in your system containing all these files in the your bin folder. Okay, now this is the path, this /bin. Okay, and you may like to again try exporting this path to your $path. So export path equal to, just type this entire thing, okay, and then colon and $path. So it will copy this path, and actually with that path the entire set of this binaries or basically program that come with the SPADES, okay, in your $path, and you will be able to execute this from anywhere in your any folder or directory in your system. Okay, this is the SPADES manual. It also give you a readme file from which you can check how to install and do these things. okay, and you can always get more information by spades.py help --help, which I also discussed earlier. So this is one of the way to get all the possible options that you can use in a program, okay. So this will become more easy and comfortable when we go further, okay, but I just want to tell you today that basically this --help works to give you the list of all the things that you can do with a program, okay. Now there is one more way which has appeared recently, that is called Conda. So basically it's called Anaconda, right, and mini Conda. So basically this is a package which allows you to install other packages. So first, if you install Conda on your system, right, then basically installation of all these packages which are and actually like a lot of packages are now available in the Conda or Anaconda folder, okay. So all the like regular use science projects and packages are available here with all the dependencies. So if you install Conda on your system first, then basically installing any such package will become like just one line job, okay. So basically it will set the environment for various programs, okay. Many times it could be that one program is using Python version this, another program is using Python version some other, okay. So you can always set those kind of dependencies also using the in the Conda environment, okay. So for example, tool A needs Python 3.6 whereas tool B needs 2.7. So this can also be handled by Conda. Otherwise what you would have done is you would have like changed the system or installed two versions of Python, and they might have, you know, created a conflict at some point of time. And virtual environments can also be created, which virtual environment we will see in the next few classes, okay. So basically now okay, so install like so Anaconda is a larger package and mini Conda is a like smaller version of that, which is equally good, and you know, generally we go for minimal installer for Conda, that is mini Conda. So download this wget, its location from internet you find out, okay. Install it, okay, by writing this script bash this -b p and $home, okay. This is the way to install, okay. This is the path, right, and binary. So basically once this is installed on your system, then basically you can just do this like Conda install, you want to install a package called Quast, okay. So just say Conda install -c bioconda Quast. So basically it will get Quast from internet, okay, wherever it is available, and basically not from wherever it is available, it is available in their repository only, the mini Conda, and it will install this package into your system, right. So for example, in my system these are all the packages that I have installed using the Anaconda, okay. So basically you may think that it may take a lot of time in installing all these one by one from internet, but okay, and they are solving their dependencies, but Anaconda provides an environment where in just one line if you just type, it will get the software from the repository and install in your system, okay. Similarly, Glimmer is a program for gene prediction, again we will see that in later for in microbial genomes, and it is a standard program which you would like to have in your system for gene prediction of microbes, right. So just to install this program, just say Conda install -c bioconda Glimmer, okay, and Glimmer will be available in the repositories of Conda and it will install in your system without any hassle, okay. Similarly, SequenceKit, which is very important for handling the sequence data. It provides so many applications and programs to, you know, dealing with sequences, and again you can install the same way Conda install -c bioconda and SeqKit. So entire SeqKit package will be installed on your system, okay. So basically in this lecture we went through the commands that we did in the previous classes, okay. We looked at how to change the file permissions in your system, and we looked at several useful commands and how to create scripts you know, to run on your system, and we also looked at how to install the various genomic packages using the directly from source pre-compiled packages, or installing through the Anaconda installer. Okay, so I think this is good for today, and then we'll meet in the next class. Thank you for today.